Hello everyone. In this video, we're going to use the external interrupt controlling the LED using the switch interrupt. Well, first things first, I'm gonna tell you what the external interrupt is. And so, since our switch is a pull-up circuit, basically when we are not pressing the switch, it remains the high state over here. But once we press the switch, it will fall down to the low state and it makes the falling edge over here. And then when we unpress the button again, it will make the rising edge. So falling edge and the rising edge is the opportunity, is the chance to make the external interrupt. So in this video, mostly I'm going to use the falling edge, but at the end of this video, I'm going to show how the rising edge works in the last of my video. And so we're going to turn off the LED first at the initialization part. But when the external interrupt happens, we're going to toggle our LED to turn on the LED. And so we're going to turn on or turn off the LED using external interrupt like this. Now let's move on to the coding part. Well, first things first, in the main function, we're going to use the clock initialization like I mentioned before in the previous video. And so, to recap, well, the H clock is now 72 megahertz and P clock 1 and P clock 2, each of them are 36 megahertz. And I'm gonna fold this long code because it is too distracting. Yeah, and on top of that, when it comes to clock configuration and LED configuration and switch configuration, we've already gone through this part in our previous videos. So if you're not familiar with this code, I recommend you to go back to my previous video and watch it again. Well, like I mentioned before, we're going to turn off the LED first at the initialization part. So if you take a look at the reference manual here, our LED is connected to port C13. So if we want to make the LED off, we have to set 1 in this beat. So if we turn this number into hexadecimal number, now it's a beat, 1 or 0, then it will be 2. So it will be 0, 0, 0, 0, 2, 0, 0, 0. There we go. So it's gonna be 0, 0, 0, 0, 2, 0, 0, 0. There we go. And then we're going to skip entire part and we're going to move on to step 4. Well, we need to enable the clock related to external interrupt. And so let's move on to the reference manual to get some hints. Well, if you take a look at the system architecture, we know that P clock 2 is related to external interrupt. So if you take a look at this table over here, we easily can find the external interrupt 0 beats are included in alternate function IO clock. So we need to enable the alternate function IO clock to use the external interrupt feature. And so if you take a look at this block diagram, it is pretty sure that peak clock 2 is supplied to the external interrupt event. So we're going to use the peak clock 2 to enable the alternate function IO clock. So our switch By the way, our switch is connected to PA0, so we're going to use the external interrupt 0. So just so you know. Well, we're going to use this part, alternate function IO clock enable beat over here. Yeah, we have to set 1 in this beat over here. So before we do that, I'm going to clear up this part first to make it sure. 0001. And then I'm going to enable the alternate function IO clock like this. Well, after that, we have to use the alternate function external interrupt control register. If you look at this part, well, like I said before, we're going to use the external interrupt 0 part since our switch is connected to PA0. So we're going to use PA pin. So we have to put 0000 in this first 4 beats like this. So if we transform these beats into a hexadecimal number, it will be 0, but we're going to use bit conversion operations, so it will be 1111, so it will be F. So since we're using the bit conversion operation and AND operation to use the external interrupt in PA0 pin, it should be 0000 F. There we go. And like I said before, we are going to use this register, but I hope you guys don't confuse with the number 1 over here. Well, since we are using the array, so we're going to use the index for it. So 1 stands for the index 0. So on top of that, just so you know, when it comes to register 2, it should be index 1. So I hope you guys don't confuse with this index number. So we should put 0 over here to use the external interrupt configuration register 1. Now let's move on to step 5. Well, we're going to configure the external interrupt 0. And so if you take a look at this reference manual over here, you can see the procedure for the hardware interrupt selection. First of all, we have to configure the mask beats using interrupt mask register over here. And then we have to select which trigger we're going to use for the edge detection. So there is the 2 options for rising edge and the falling edge. In this case, we're going to use falling edge. So let's move on to over here. Well, we're going to set the mask interrupt first, and then we're going to select the edge, and then we're going to set the pending bit. So this is the entire procedure for the external interrupt setting. So let's move on to the reference manual. So, well, our external interrupt name is external interrupt 0. So our beat is mask register 0 over here. So we need to unmask this part. So I'm gonna put 0000 to unmask the PA0 external interrupt. And then we're going to set the falling edge Well, over here, so um, we have to put 1 in this part over here. So it's going to be 0, 0, 0, 0, 0, 0, 0, 1. There we go. Just so you know, if you want to select the rising edge over here instead of falling edge, we have to write down XTI rising trigger selection register. Rising trigger selection register to 0, 0, 0, 0, 0, 0, 0, 1. There we go. This is about the rising edge detection code, but we're not going to use the rising edge at this point, just so you know. And lastly, we're going to set the pending bit. Well, yeah, we have to set this part to 1 to select the trigger request occurred. And so we have to make the selected trigger request, which is falling edge, occurred to set this bit to 1. So in this case, we're going to use the equal operation to, you know, directly write down 1 in this bit. So it should be 1, 0, 0, 0, 0, 0, 0, 0, 1. Now let's move on to step 6. Well, we have to enable the NDIC interrupt request. So to write down the parameter over here, we have to search for which parameter is the right parameter for our interrupt. So just so you know, we're going to use this uh, external interrupt line 0 interrupt. So if you go into this function, there is the entire list for the specific interrupts. Ours are over here. So just copy and paste it. There we go. Well, for the last step, we need to complete this IRQ handler function to toggle our LED whenever the interrupt occurs. So to do that, we have to check the pending register beat over here to check whether these beats are set or clear, 1 or 0, I mean. So if you read this part over here, this beat is set when the selected edge event, which is the falling edge in our case, arrives on the external interrupt line. So we need to check uh, the beat 0 to detect the falling edge. So it will be 0, 0, 0, 0, 0, 0, 0, 1 because there is the AND operation to check the beat. And after that, if you take a look at this reference manual again, this beat is cleared by writing a 1 into the beat. So we need to clear this beat again after the interrupt occurred because we need to detect the further interrupts in the near future. So yeah, we're going to put writing 1 in this beat again to clear the pending beat. So like this. And finally, we're going to toggle the LED using this exclusive OR operation over here. So if you go to the reference manual, which is output data register over here, our LED is connected to port C13. So we have to toggle the speed. So it will be 1 over here. So the rest of them are all 0. So this is one chunk, one chunk, one chunk, and one chunk. And the rest of the beats here is all 0. So it would be 2, 0, 0, 0. So it would be 0, 0, 0, 0, 2, 0, 0, 0. There we go. And now I'm gonna execute this GPIO external interrupt related function in the main function I mean. And then I'm going to write down this blank while loop waiting for the external interrupt. And lastly, I'm gonna build this project. Well, the build is completed without any other errors. Well, I just unloaded the code, and if I press the switch over here, and if I press the switch again, the LED is toggled. And so one thing you take care about carefully, right after I press the switch, it detects the falling edge. So the LED is toggled at this moment. And once again, right after I press the switch, the LED is toggled again. Well, I just unloaded the code with the rising edge detection version. And the one big difference in this code is that, right after I unpress the switch, the LED is toggled like this. And once again, right after I unpress the switch, the LED is toggled. Well, just to make sure, you should choose either the falling edge or the rising edge. Well, not both. You have to choose only one, like this. Well, this is all about today's tutorial, and I hope you find it very useful through this video. And so, yeah, thanks for watching, and see you on my next video. Bye, guys.